The design concept presentation is on a tidal barrage on the Thames estuary. The presentation will cover the design brief and how we addressed it by investigating different sources of tidal energy, the preliminary stages of design and who is affected by the barrage, technical information about the barrage and turbines, and finally time management for Term 2 building up to the presentation in Term 3. The design brief was to create an environmentally sustainable source of energy which utilises the power from the sea. We highlighted sustainability as a key factor within the design and concluded that the design must be environmentally sustainable. This means energy has to be free of CO2 and other harmful gases. This means there must be a minimal impact also on the local ecosystem. It must also be economically sustainable. This means it must be cost effective and in good investment for companies, also providing jobs for the locals, boosting the surrounding economy.
To address the challenge, we looked at the main methods used to produce energy from the sea. We found the most common methods used were tidal barrages, tidal streams, point absorbers, and attenuators. From our initial research, we found that tidal barrages have multiple uses such as energy generation, flood defense, and transport links. We also found that a tidal barrage produces much more energy than the other generation methods, but also costs a lot more to build. We found there are multiple types of turbines used for tidal stream generation. These are axial turbines, cross-flow turbines, tidal kites, and flow-augmented turbines. Tidal streams produce between 0.3 and 1.2 megawatts of energy and have a predicted lifespan of 25 years. We found that point absorbers are relatively small and produce continuous energy that can be transported back to shore via underwater cables. Due to their size and energy production, point absorbers are normally produced in arrays. Point absorbers have a lifespan of around 25 years and produce in the range of 50 to 200 kilowatts of energy. From our research, we found that attenuators convert wave energy into electrical energy to produce a smooth and continuous output. Attenuators produce roughly 750 kilowatts and cost in the region of £2.5 million to produce. Design of 4 different criteria. The chosen criteria were the effect on surrounding people, the effect on wildlife, cost against return, and energy production. As a group, we gave each design a rating between 1 and 5 for each criteria, 1 being poor and 5 being excellent. We tabulated our results and then selected the highest score.
The barrage is primarily based on Lorient in France, which is the only operating tidal barrage in the world. It will stretch 2 kilometres across the Thames estuary between Corningham on the north shore and Clith on the south.
The Thames was chosen due to its high tidal range of up to 7 metres, but also because the barrage will be given a dual role of safeguarding London from flooding, releasing the pressure on the Thames barrier. This is an exploded view of the 10 megawatt rated turbine used within the barrage. There will be 24 of these able to produce 525 gigawatt hours of energy per year. Ebb generation is the favoured method for turbines to operate, producing large amounts of power over 4-hour stints to meet the needs at peak times. This is a computer-aided design model of the barrage. The design will incorporate a road along the top to ease traffic around London. This will give access across the Thames, decreasing journey times for the local residents. Due to the water traffic on the Thames, a large lock will be built on the southern side of the barrage and will operate at scheduled times to decrease the wait time for traffic. There will also be a raisable part of the bridge to allow taller boats to pass through. Multiple boats will be able to pass through the barrage at once as well. The barrage will also house 24 turbines which will be connected to a power station. This will be located on the northern side of the river. A fishway will be fitted on either side of the barrage. This will allow fish to make their way over the structure to migrate up and downstream. Fish screens will also be fitted to avoid them swimming into the turbines, directing them towards the fishway. The image below shows the Thames as it is today, followed by what it would look like without current flood defence systems such as the Thames barrier, which goes out of date by 2030. The Thames Barrage project would replace the barrier and safeguard London for up to 100 years. The Thames Barrage project will affect large populations of London. The barrage will protect £200 billion worth of property and infrastructure, a large proportion of the London's tube network and many historic buildings, power supplies, hospitals and schools. It will also protect the UK's largest urban cluster of economic activity, contributing to some £250 billion worth in goods and services annually. In order for the barrage to become a reality, it is essential that there is backing from the government or private energy firms. It is a long-term investment which would aim to pay itself off after 20 years. Existing plans estimate that it would cost £5 billion to build a tidal energy barrage on the Thames. Opposition to the barrage can be met from environmental agencies. Therefore, to ensure government backing, environmental factors must be addressed. For example, the barrage must not have any carbon emissions, waste products, and ensure that the damage to the natural habitat is minimal.
There are over 100 different species of fish in the Thames, including carp, bream, pike, and several species of mullet, and around 350 species of benthic invertebrates. Within the Thames River Basin there are 46 internationally designated special protection areas, which ensures that any new development scheme will not adversely affect the integrity of the surrounding wildlife. Some of the effects a tidal barrage could have on the Thames is that it could hamper fish migration as it would interfere with the tides. This could also lead to an increase in pollution, as the tides will have less time to remove any dirty water. The construction of the tidal barrage could alter or destroy the habitats of the river wildlife, and also puts the fish at risk of swimming into the turbines.
Fishways and fish screens have therefore been incorporated into the design to reduce the impact on the environment, with further investigation into the possibility of floodplains and salt marshes further downstream. We have used a Gantt chart to manage our time for Term 2. There are 2 key dates to work towards: Wednesday the 26th of March, when the report's due in, and then the presentation on the 30th of April. To meet the deadlines, we will continue weekly team meetings with individual research into specific areas carried out over the preceding week. We will aim to have all the research concluded by February 25th to begin work on the report.
This video presentation has given you an overview of the preliminary designs of our tidal barrage. Whilst this was the main focus of the group's effort, it is not the only thing that we have learnt while doing this project. We have gained important team working skills such as time management, problem solving, equal work weight, quality control, and finally learning to work in a team.